Hi everyone, in this video let's look at there is a constraint solve before can be used inside a constraint block. Let's see how that works. We have a class here and rand bit x which can take values 0 or 1, and we have another variable y which is of rand where data type of bit 1 down to 0 which can take values from 0, 1, 2, 3. And the constraint here is like x is equal to implies y is equal to 0. X is equal to 0 implies y is equal to 0. What, as we saw in previous videos, if x is 0, y must be 0 and reverse is not true. Okay. Now we have another constraint which is called solve x before y, as the statement says, solve x before y. First, now when you solve this two random values, the first preference is for the x. That's what this does. This is like guiding distribution which will give first solve the x then y. Let's see what will be the solution probabilities when we add this additional constraint here. Now we see like solve x, like what are the possible values for x when we solve, like 50 times 50% of the time we'll see 0, 50% of the time we'll see 1. So this total solution space available is like 8 sets are possible. Out of them we you will type 50 times 0 for x, 50 times 0 for 1. So the probability of getting 0 is 1 by 2, the probability of getting 1 for x is 1 by 2. When you get x as 0 and there is no other, as this constraint says when x is 0, y will be 0. In that case these three set of values are not possible. So only this is possible. The probability of getting this set is 1 by 2 and the probability of getting this set is 1 by 2, and when x is 1 there is no condition, y can be anything. So 1 by 2 divided by 4 which is 1 by 8. The probability of getting each set is 1 by 8. Let's look at another example. In this example, what we did in the same example, what we did is we changed this solve y before x. We just reversed in the previous example. Now we gave preference to y. First solve, the first variable need to be solved is y and then x. So what happens if if y solves first? We will give first equal probability for all the values 0, 1, 2, 3, 4. Like each value will get probability of 1 by 4. Okay. Now this set each 0 gets the probability of 1 by 4 and 1 gets the probability of 1 by 4. Let's look at 0. When y is 0, there is a the reverse is not true, right? Y is 0, x can be 0 or 1, like the other way is true, right? This is not true. When y is 0, x can be 0. The preference of this constraint is minimal here, or not used also, we can say. Only use here is like this set of this constraint is like this set won't be visible. Like now first we are solving y, right? So the reverse, this is not bidirectional, the reverse is not true. When y is 0, x need not be 0, or there is x can be 1 also, but when x is 1, y should be 0. So that's why what happens is the probability of for 0 we have two probabilities, like x can be 0 or x can be 1. Then we will get the probability of getting each value is 1 by 4 divided by 2, which is 1 by 8. Similarly, for when y is 1, this is ruled out, and y is 1, this is ruled out, and only possible value for the x is this is ruled out because of this constraint. X cannot be y should not be 1 when x is 0. Because of this constraint, this is ruled out. So when y is this is the only constant possible. That's why we have 1 by 4. Similarly 2 and 3. Hope you understand. Thanks.